Hello everyone, this is Dr. G. Karthik Reddy, working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. Today's session topic is problems on mean ergodic and correlation ergodic. Today's overview is, we are going to discuss on problems on mean ergodic and problems on correlation ergodic. First of all, what is ergodic? The ergodic tells that, the time average, in terms of mean ergodic, it tells that the time average must be equal to ensembled average. The time average must be equal to ensembled average. It is denoted as A of x of t is equal to expectation of x of t, or sometimes they will represent this as x of t bar. Here time average must be equal to ensembled average, then the condition is said to be mean ergodic. Ensembled average, you are having the formula same as expectation of x of t. For continuous random variable, integration minus infinity to infinity, that small x of t into fx of x comma t dx. This is a general ensembled average formula. Ensembled average we are taking for n number of, for example, this is one of the random signal, this is a second random signal, this is a third random signal. Channel on the noise on the first instant, on second instant and third instant. For example, this is T1, this is T2. Now we are calculating the ensembled average. Ensembled average is always calculated for a fixed time. For example, at T1, fixed at T1, you are going to get the random variables x1, for example, this one x of t, x1, x2, so on up to xn. When you take the summation of all those terms, then in terms of in terms of integration, whatever you are doing, that is called ensembled average. The next time average we are always taking for particular sample function or particular random process. Here you are having the T1 to T2, T3 up to Tn. You are taking for one complete sample function. For complete one sample function or random process, this T1 to Tn instance. For only for particular what is that, random process, then that is called time average. The time average is denoted as, the formula is limit t tends to infinity. Whatever you are having, the x of t. It is denoted as like this. This is a time average. Limit t tends to infinity. Whatever the term you are having, x of t. Here you are having the integral minus infinity to infinity. Here 1 by 2t. X of t dt. This is a formula for time average. Now similarly, we are going to discuss about the correlation ergodic. Correlation ergodic, you are having two cases. One is autocorrelation ergodic. Second one is cross correlation ergodic. First one is autocorrelation ergodic. It tells that auto time average, auto time means x of t into x of t plus tau must be equal to ensemble one. Autocorrelation. Auto means same signal with its delayed version. This is the time. This is called autocorrelation ergodic. Then cross correlation ergodic means we are having two different random process, that is x of t, y of t plus tau of time, which is equal to expectation of x of t, y of t plus tau. RHS part whatever you are having, ensemble one. LHS part whatever you are having, that is time. This is for auto correlation ergodic condition. This is cross correlation ergodic condition. This is a cross correlation ergodic condition. This is auto correlation ergodic condition. The formula is same, integral term. Here you are having for time ergodic, time autocorrelation ergodic, you are having limit t tends to infinity, Okay, whatever the interval 1 by 2t. Okay, here minus infinity infinity, here x of t into x of t plus tau dt. Okay, here then what you are going to get here, you know the formula, that directly you have to use the autocorrelation formula only. You have to apply this. Here we have to use the cross correlation formula. Okay, it is also denoted in the form of, okay, autocorrelation-Ergodic means R xx of tau. Okay, the one more line it is adding. This is called time autocorrelation is equal to ensembled autocorrelation. This is one of the form of notation of autocorrelation-Ergodic. Then cross correlation-Ergodic Rxy. Okay, before R you draw one line. This represents the time cross correlation-Ergodic. Okay, this is equal to, because this is called with respect to time. Okay, this is ensemble one. Okay, now we will discuss the problems related to these concepts. Okay, same thing we have discussed here. Okay, this is the time average function. Okay, x bar a of x of t, limit t tends to infinity 1 by 2t integral minus t to t x of t dt. Next, time autocorrelation sense. Okay, it is denoted in this form. Okay, the formula related to this. Okay, limit t tends to infinity 1 by 2t integral minus t to this. Okay, this is a common form, either time average or time autocorrelation. Here in place of x of t, you are having x of t into x of t plus tau. Okay, now next, here having the time mean square also you can calculate. Okay, a into x square of t, limit t tends to infinity 1 by 2t integral minus t to t. This term is common for time, okay, average or time autocorrelation or time mean square. Here x square you have to include in place of x of t for mean. Next, time cross correlation, again this is a notation r xy of tau. Okay, r xy of tau, limit t tends to infinity 1 by 2t minus t to t. This is a common one. Here x of t into y of t plus tau, because we are using two different random process. Okay, ergodic. Okay, just now I discussed mean ergodic time. Okay, this is the notation of ensemble and this is the notation of time. Okay, this is autocorrelation notation, autocorrelation of time and autocorrelation of ensemble. Jointly ergodic you are going to get whenever you are using the cross terminology. Okay, cross terminology. This is the time and this is a means like this. Okay, time part and this is a auto part. Okay, now next we are discussing the problem related to the mean ergodic and correlation ergodic. Okay, here they are given in the question that a random process x of t is defined such that x of t equal to a into cos of omega naught t plus phi. What is omega naught? Is the angular frequency, t is the time, phi is the phase change, a is the amplitude. And here first you have to identify what are the constants you are having. Okay, here given in the question that constant, a is a constant, omega naught is a fixed frequency, means it is a constant, phi is changing here. Here what is a variable? You have to identify it. Phi is the uniformly distributed random variable which is defined in the interval 0, 2 pi. And here is the independent of time t. Means here focus on which is a random variable, that is it is defined as uniformly random variable. Then what is the definition of uniform random variable? Uniform random variable is defined for a particular interval, that is f of phi, means we have to calculate the density function before solving the problem. Okay, which is equal to, which is defined between 0 to 2 pi interval. Okay, 1 by 2 pi minus 0, which is defined, okay, in the interval 0, 5, 2 pi, 0 otherwise. 0 otherwise. Means what is the final answer you will get? F of phi is equal to 1 by 2 pi for the interval 0 less than or equal to 5 less than or equal to 2 pi, 0 otherwise. Okay, first you have to solve the density function of the random variable. Here it is defined as uniformly distributed random variable. That is why we are solving the uniform density function of that particular random variable. Now after solving this, now we have to identify the mean ergodic and correlation ergodic. First we will solve the mean ergodic. Just now we discussed the mean ergodic. Ensembled average equal to the time average. We have to solve both and we have to check that whether both are equal or not. If both are equal, then we can conclude that it is a mean ergodic. If both are not equal, it is not a mean ergodic. The given whatever the random process is not mean ergodic. First we'll check that one. Okay, here the problem tells that mean ergodic. Okay, the first definition is that the time average of the process must be equal to the ensembled average. Okay, the expected value. Okay, this is the time average formula, but here it is defined. Okay, here it is what it is defined. It is defined between 0 to 2 pi, 0 to 2 pi interval. Okay, 0 to, okay, positive value 0 to t x of t. Okay, 1 by 2 t, okay, x of t. Next here, first you have to calculate the ensembled average. Okay, ensembled average. Ensembled average is a basic expectation formula only. Okay, expectation formula. Okay, here the 0 to 2 pi a cos y. Okay, what is the expectation formula? Just you have to substitute that. In place of x of t, whatever you are having, you have to substitute here d phi. Then what you are going to get? Simplify this one. Okay, cos term, when you apply the interval from 0 to 2 pi. Okay, it repeats for every 2 pi cycle. Then what happens? The positive and negative peak will get cancel each other. Positive and negative peak will get cancel each other. Then the resultant you will get 0. That is here is discussing about that. Means the whatever you are going to get the ensemble average, which is 0. Now we have to check that whether the time average is also getting 0 or not. We have to check it based on the condition. Whatever the condition you are having, this is having the positive interval. Okay, based on that condition, okay, you apply that 0 to t or time period whenever considering the 0 to 2 pi cycle of that particular interval. Okay, here f of 1 by 2 pi represents what? Means f of theta. F of theta. Here the condition, whatever you are having 0 to 2 pi a into cos of omega naught t plus phi f of phi d phi. Here f of phi is 1 by 2 pi. Okay, now next here time average 1 by pi 0 to t x of t dt. You substitute that. Here it repeats at regular 2 pi interval. Okay, but always a positive peak and negative peak of the sinusoidal, means either cos or sin term will get cancel out each other. Then the resultant you are going to get 0. Okay, both are getting zeros. Okay, then we are concluding that it is satisfying the mean ergodic. Okay, mean ergodic, that is time average is equal to ensembled average. Now next we are going to discuss about the correlation ergodic. Next question, it is given in the question that correlation ergodic. What is correlation ergodic? Okay, correlation ergodic we are calculating based on autocorrelation sense or cross correlation sense. If they did not mention anything, you can calculate either any one. Okay, now we are calculating on correlation ergodic. Correlation ergodic we are telling, for example, if you are taking the autocorrelation one, means the time average of the autocorrelation function must be equal to the ensembled average, ensemble autocorrelation function. Ensemble autocorrelation function means that is a general autocorrelation function only. Okay, the time autocorrelation, okay, the time sense, okay, this is a ensemble sense. Okay, ensemble one formula is expectation of x of t into x of t plus tau. Here having the formula autocorrelation rxx of tau is equal to expectation of x of t into x of t plus tau. You substitute that. Here having the formula expectation of x of t a into cos of omega naught t plus phi. Next, x of t plus tau means a into cos of omega naught t plus tau plus phi. Now you multiply it, you are going to get expectation of a square cos omega naught t plus phi cos omega naught t omega naught tau plus phi. Okay, now same expression they given here. Okay, now what you have to use the trigonometric identity. Okay, multiply and divided by 2. Okay, you take a outside. Okay, then it will be in the form of, okay, multiply and divided by 2, then it is in the form of what? Okay, expectation of 2 cos of omega naught t plus phi cos of omega naught t omega naught phi plus theta. Okay, then it is in the form of 2 cos a cos b. 2 cos a cos b. We are having the formula cos of a minus b plus cos of a plus b. Okay, this one you can consider as a term and this one you can consider as b term, and if you simplify it, you will get this is the resultant you are going to get. Then what you have to do, apply the, after finishing that, you have to apply the expectation for individual terms. individual terms you have to apply the expectation. Okay, this is the first term. First term, if you are applying the expectation, that is expectation of cos omega naught tau. Okay, here cos omega naught tau you have to apply. Then here it is the interval 0 to 2 pi cos omega naught tau. Next, what you are having, d tau or dx. Okay, here you are taking in terms of phi. Okay, phi. Okay, cos omega naught tau, which is not with respect to phi, it is constant. You can take outside. Okay, cos omega naught phi. Okay, now you are having a square by 2. Anyhow, we are having the constant. A square by 2, you are having the constant. Okay, now you are having only the remaining term you are having. Okay, a square by 2. Okay, you are having the cos term whenever you are doing the integration of the cos. This is a constant, take outside that, then whatever you are having, that resultant you are going to get this. Now next, we are having the second term. Second term, it is repeating for every 2 pi cycle. Okay, the here 2 pi, 4 pi you will get cos 4 pi, again it will come the same term. This term only will get minus of that term, both will cancel each other. Then the resultant, this term become 0. Then you are having only the a square by 2 cos omega naught tau, only the resultant answer you are going to get. Okay, resultant answer you are going to get. This is the whatever we have calculated, this is the ensemble average. Next, similarly, you can calculate the time average. The time average, okay, the time average you are having, okay, the time average, this is a formula. Okay, 1 by, okay, whatever the interval you are having, 1 by t, 0 to t, x of t. Okay, again the x of t, x square of t we already solved. Then cos omega naught tau plus cos 2 omega naught t plus omega naught tau plus 2 phi. Okay, again the same approach you follow it. Okay, again the same approach we have to follow it. Here, whatever the constant is there, you take outside a square by 2. Okay, limit t tends to infinity. Here, whatever you are having d phi, we are having d phi. Then whatever you are having t will get cancel each other. 1 by t will get cancel each other. Then the limit, okay, the independent of t will become a square by 2 cos omega tau you will get, because here this is a constant, take outside the interval. Then you are going to get a square by 2 cos omega naught tau you are going to get. And this term again the cycle will repeat. Then only you are going to get 0 of this term you will get. Here also you will get a square by 2 cos omega naught tau. This is for time autocorrelation sense. Similarly, you can calculate the, okay, here you are having only the x of t. Here we are having the question, in the question what you are having, only x of t you are having. That is why we can use only the autocorrelation-Ergodic. If you are having two signals instead of x of t, we are having x of t and some y of t equal to some b sine omega naught t plus phi. Whenever you are having two signals, again you have to apply same formula, whatever you are having. Okay, here you are having in place of x, you are having y, and you are having here r xy of tau. Here also in place of x, you are having y. Okay, similarly you have to satisfy the time average of cross correlation function is equal to ensemble average of cross correlation function. If it is satisfied, then it is called cross correlation ergodic. Okay. Okay, in this section we have observed that, okay, how to solve the problems related to the mean ergodic and correlation ergodic. Okay, how if the conditions are satisfied, okay, the time average of the mean and time ensemble average, if both are equal, then it is called mean ergodic. And if the autocorrelation also, if only x of t is there, you can solve autocorrelation in time and ensemble one. If both are equal, then it is called autocorrelation ergodic. If two different random process if they have given, then we can give, that is called cross correlation ergodic. Okay, thank you.